Okay, so this video is going to go over the basic tools for geometry. And these are really basic tools for geometry. A lot of this stuff you will have learned way back in elementary, and it'll be just a reminder. For example, point. Point is just a specific location in space, and it's always signified by a capital letter, like point A. So it's a specific location, and I'm going to give you definitions of these, so I'm not going to write them down, I'm just going to speak them. And then the next one's going to be a line. A line goes on forever in both directions, and it's denoted by arrows on both sides, and it also has points on it. It has to at least have 2 points. In fact, it has infinitely many points. But let's say it had BC. This could be called line BC, or it could be called line CB. Both of those are fine. And again, it has infinitely many points in between those, but they might not be written. The next definition is a line segment. Line segments don't have the arrows on them, which means they don't go on forever and ever. And this is generally what we use because we can measure this. Let's say it was a D and an E, and this would be line segment DE or line segment ED. And again, this is the most common. In reality, lines don't exist because nothing really goes on forever and ever and ever and ever, maybe eternity. But in real life, everything stops. And so most of our things are line segments. But notice the difference in how you write them. A line, when you write it, has the arrows on the top, and a line segment doesn't. And when you say this out loud, this reads line segment DE, line segment ED, line CB, line BC. Okay, array. Array is very similar. It starts with a line segment. It starts with a point, and it goes on in one direction forever, but it stops in the other. So let's say, what do we leave off with? E, so let's go with F, and we'll put a point here and we'll call it G. Now, the thing about array is it can only have one name. Like this is ray FG. It cannot be named ray GF because you can't change the arrow around. It starts at F and it goes toward G. It's not the other way around. So notice how all so far these two had 2 names. Rays don't have 2 names. They only have 1. Okay. The next thing that you need to know is, let's say that you have a line segment, and let's say it's A. So we got A, B, C, and let's say it's marked like this. So what that means is that B is the midpoint, because what this marking means that these 2 line segments are congruent. For example, line segment AB and line segment BC are congruent. So line segment AB is congruent to line segment BC. That's what that marking means. And if they were marked like this, as long as they have the same markings, that means they're the same measure. Now if they had different markings, let's say it was a triangle, then they're not congruent. This is one marking, this is a different marking. They're not the same. But if they have the same markings, then they have the same measure, which means they're congruent. And this is the congruent symbol. It has an equal with a swiggle. That means congruent. And congruent means equal in measure and equal in size. So let's write that down. Equal in measure and equal in size. That's an S. Doesn't look like an S, but it is an S. So a lot to take in. Let's highlight some key words here. Congruent, midpoint, congruent symbol, ray, line segment, line, point. Let's see. Okay, let's keep going here. What else do you need to know to keep going? Of course, angle. Let's go to angle. How to name an angle. A lot of kids have trouble naming angles. Let's just draw one angle. Okay, so angles are two rays connected at a vertex. Let's write that down. Angles are two rays connected at a vertex. So this is the vertex. And we'll give it some letters. Let's say A, B, and C. And let's go ahead and give it a number 2. I don't know why exactly kids have such a hard time naming angles, but they really do. They really struggle with it. So if you were going to trace the angle, that's exactly how you would name it. So start with one of the arrows and just trace it and go to the other arrow. Literally, that's it. So one of the ends of the rays, and then come to the vertex and then go to the other one. So it's like A, B, C. That's how you do it. So this would be angle A, B, C. Or we could start over here and go C, B, A. Now if the angle is alone, like this one is, you can name it just by the vertex. So angle B is also an option. And then there's one last option. If it's numbered, like this one, you can also name it by its number. So this one has 4 ways to name it. And when it asks you to name the angle, not classify. Classify and name are not the same thing. Naming an angle is to trace it with your finger. Name, trace. Okay? Classify means to say whether it's acute or obtuse or right or straight. That is not the same as naming the angle. So make sure you know what it's asking you, because sometimes when it says name the angle, a kid will say something like it's obtuse. That wasn't the question. Okay, so just to clarify, classifying and naming angles are not the same thing. If they ask you to classify an angle, they're asking for either acute, right, obtuse, or straight. If they're asking you to name an angle, they're looking for answers like angle ABC, or possibly angle CBA. You know, it's not going to be one of these answers probably, but it'll be something like this. So just know that these are not the same. In fact, let's go ahead and talk about acute, right, obtuse, and straight. Acute angles. Acute angles are angles that measure between, I guess technically 0, even though 0 wouldn't be possible because the angle wouldn't exist, but 0 and 90. Wouldn't it be exactly 90? Well, this is probably actually right, because it can't be 0. It has to be greater than 0, but it can't be 90. It has to be less than 90. So it has to be like maybe 1 or maybe 89. So in between 0 and 90. Can't be 90 exactly, and it can't be greater than 90. It has to be less than 90, but greater than 0. So for example, in between 1 and 89, that would be an acute angle. All right, a right triangle, well, it could be a triangle, but a right angle is exactly, oops, got my L, 90 degrees. This one is a special one because it can't be anything else. It can't be 90.1, it can't be 91 degrees, it can't be 95 degrees. It has to be 90 exactly. And you can tell that it's 90 because it always puts a little box there, like a little tiny square. And that means 90 degrees. And if there's one 90-degree angle, there's automatically 4 90-degree angles. And they don't tell you that. That's kind of like an understood thing. If there's one, there's automatically 4 of them. So just something to know. It's kind of like where there's one mouse, there's more than one. Where there's one right angle, there's 4 right angles. Which is kind of gross because I hate mice, but anyway. Okay, obtuse, you can probably guess by now. Obtuse angles are more than 90 degrees. Are angles that measure between 90 and 180. They're not 180. They cannot be 180, but they cannot be 90 either. They fall in between that. So they're actually in between 91 and 179. Okay? If you were doing whole numbers. but they can be like 90.1 and 179.9. These are just whole numbers, just to help you understand. But it cannot be exactly 90 because that would be a right angle. And it can't be exactly 180 because that would be a straight angle, which is what we're going to talk about next. So, obtuse angles are really big angles. And they look like this. They're like kind of like a wide mouth. And I always thought about obtuse as being obese, like somebody would have to really have a big mouth to be able to eat a lot. And so they have a really wide mouth. And an acute angle is really cute, like a little baby, like a cute little angle. And then a right angle is, of course, the one with the square, and it's perfect, always perfect, just right. Looks like a present, you know, especially with all four of them. I'm going to move this over so you can see that again. It kind of looks like a present. It's just right. And then you have the straight angle. And it's exactly 180 degrees. And it looks like a straight line. Makes sense, right? Straight angle, straight line. And it looks like a sunset. Straight angle, I always thought about it like S for straight angle and S for sunset. So think about that. Okay, what else are we going to go over? All right. Just 4 more things and then this video will be done. The next thing we're going to go over is parallel lines. Parallel lines, these are horrible parallel lines, but in theory, they would be exactly the same width apart at every point. These are obviously not, but I'm not very good at drawing them. Parallel lines would never intersect. And they're in the same plane though, but they never ever intersect. And in real life, the best example of parallel lines would be railroad tracks. They're the same distance apart, no matter at every point of the way. And I mean, they're not really straight, but that's okay. They do follow the same rule that they are the same distance apart. They never intersect, and they're in the same plane. So they're the best example of real life scenarios of parallel lines. The other one that we're going to go over is perpendicular lines. And that's when they intersect at 90-degree angles. And perpendicular. And so these intersect, as you can see, at 90 degrees. So I don't know if we should draw so you can see the difference there. Parallel lines, these never intersect, but perpendicular lines do intersect, and they intersect at exactly 90-degree angles. So let's write the symbols. Parallel lines have symbols that we write. So let's write line AB is parallel to line CD. Okay, that's how you would write that. This reads line AB is parallel to line CD. So let's write the symbol for perpendicular down here. Line AB is perpendicular to line CD. This is the symbol for perpendicular. So just so you know, geometry has a lot of symbols and a lot of shorthand. And you read the like eventually this is all they'll write, and you'll just read it like a sentence, and you'll be expected to read it just like you would a novel, and there'll be a sequence of symbols like this, and they'll be separated by commas or semicolons, and you'll just read them like a sentence, like a paragraph. And if you don't know the symbols, then it'll be very confusing. So make sure that you pick up on the symbols and you take notes and you try to memorize them. So parallel, perpendicular. Okay, 2 more words and then we'll be done. These words don't really get used that often, but you still need to know them. In fact, I don't remember the last time I used them outside of math. Collinear means exactly what you think it would mean. If you break it down, co means to share, like co-ed, boys and girls are together, you know, sharing a school. So something's going to share, and they share the line. So somebody's going to share a line. And collinear means that points share a line. And more than that, it's three or more points share a line. So we got a line and we have 3 or more points on that line. So that means collinear. And then coplanar is very similar. We got co, meaning to share, and then we have plane, and a plane is, in geometry, is like a space, it's like a location. And if points are coplanar, that means they all lie in the same plane. So it's kind of self-explanatory. I can't remember the last time someone said that in a sentence, that something was collinear or coplanar, but you still need to know what it means in case it comes up. But when you break the words down, it makes sense. So I don't think it's going to be very hard for you. Okay, so that's the notes, and then I'm going to give you a printout that looks like this. And the definitions are on here with some pictures, illustrations, and I want you to keep these, obviously. And you should also have notes. If you don't have notes like this, you won't get credit for your notes. If you have any questions, feel free to ask.